Good morning, everyone. My name is Jeremy Grofroca, and I am the Customer Center Manager for GE Healthcare here in Europe. I am really glad today to virtually welcome you for the third time for RSNA 2020 here in our Customer Center in Buc. I really hope you will enjoy the session. Here you have the SIGNA Architect. This is a system that we will use for this presentation today. Before to go further, let me just introduce you first, Rachid Majou, who is our clinical leader for Neuro and MSK. He will be with us during the whole session. And also Bastien Perez, who is the marketing manager for 1.5 Tesla in Europe, and he will be our moderator during the session today.
Good morning, everybody.
So please feel free to ask any question in the chat. Bastien will follow during the presentation, and we will dedicate time at the end of the session to answer your question. If we are ready, let's jump on our subject of today. So today it will be the MSK session, and more specifically, expanding capabilities while enhancing productivity and image quality. If you were with us on Monday morning, we talked a lot about productivity. We demonstrated that by using our last development, our last solutions, you are able to improve your productivity while maintaining or even more improving your image quality. We will demonstrate quite the same during the presentation today for MSK imaging. But today, I want to add one more challenge, because if you are used to work with MSK examination, you are probably using a lot rigid dedicated coil. Rigid dedicated coils are for sure really great coils, but they still have some challenges. Sometimes your morphology of your patient will not fit the coil, or sometimes also the coverage that this kind of coil will deliver you will not be enough to achieve the examination that you are expecting. This is why today we will use the 30 element channel anterior array air coil to perform MSK examination. You will probably think that it's quite weird to start an MSK presentation by demonstrating an anterior coil, but first of all, this air coil is really versatile. And this is what we will try to demonstrate to you today, that with this huge flexibility, we are able to wrap this coil around any type of anatomy. And in the meantime, by doing that, you can also overlap the elements on themselves without any penalty in terms of signal-noise ratio. And also, this coil has a huge coverage. So by combining all those characteristics, we will try to achieve really high image quality MSK examination in a short time. Let me just now show you the positioning of the patient, which is also critical when we are talking about MSK. So here we have our volunteer on the table, ready to be scanned, and I will show you the positioning for a leg examination. As we are in the magnet room, I will have to remove my headset just during the time that I'm positioning, and I come back just after. So have a look on what I'm doing.
And there is a reason why Jeremy is showing you the leg examination. It would have been too easy to just demonstrate an EMR procedure. What we really want to show you here is how the air coil is capable of delivering super good image quality, patient comfort, but also, sorry, I'm meeting somebody in the lobby, and quick positioning when it comes to the technologist. Back to you, Jeremy.
Thank you, Bastien. So here we are. Positioning is done. You can see that we wrap the coil around the leg of our patient, and it looks that our volunteer is pretty well installed. We have comfort pad positioning under the knee, so which gives us the possibility to achieve nice image quality. So let's start. What we want now is to scan. So for that, first we need to create our landmark. We will use what we call IntelliTouch, the sensitive strip band that you can see here on the side of the table. Only one finger, and I will press where I want to create my landmark, and then that's okay. I can send my patient in the bore and we can start the scanning. So I'll see you in a minute at the operator console to start the scanning. See you.
When Jeremy showed you the air coil on his chest, I think it's important to mention that Jeremy is almost 1 meter and 90 centimeters. So it's really telling you the superior to inferior coverage that you can have with the air coil. That helps you, for example, to do an entire chest, abdomen, and pelvic examination without having to reposition the coil inside the scanning room. And now I think Jeremy and Rashid are ready for the scanning part. I can have a look at the user interface, so I'll give the ball over to them again.
Thank you, Bastien. Thank you. So here we are at the operator console. Let me run the first localizer. So as we said, we will try to do quite a lot of things during this scanning session. We will start here by a knee examination, full knee examination, I mean. And then we will go down to the leg with several sequences. We will try to show you all the capabilities of this air coil. So with large field of view and also higher spatial resolution. And we will finish the session by an ankle sequence. So let me position the first sequence. So we have our localizer here. So we are doing here, we said improving quality and productivity. To do so, we will use one of our last development we called RSNA. So RSNA is a deep learning based reconstruction algorithm which will work specifically on the raw data at the raw data level to depict and specifically remove noise and GIFs artifact. So by doing that, we will improve SNR and sharpness in our images. This is why we will be able to scan faster and also by improving our image quality. So here we have our first sequence, T1 sagittal, 1 minute 46 with a 0.4 by 0.4 in plane resolution and 3 millimeter slice thickness. Let's run it. Okay. Here, let's open a PDFAT sagittal. So you can see we created a smart link between the two sequences. So my sequence is already positioned. We talked about RSNA. At the operator console, you can see here that you have this tab where the user can pick the level of the algorithm that you want to use, high, medium, and low. So I mean the user is keeping the control on the images and on the images, and you can do really what you want with this RSNA algorithm. Again, our subject today is not to show you that you can scan with a flexible with the air coil for MSK. Is to show you that you can achieve a high image quality with air coil in exactly the same time that you would probably scan with a rigid coil. Let's now position the axle. So we are running, I think, quite the same kind of protocol that you are, I think, currently using.
I quite like, Jeremy, all the sequences you have in the task list, because I don't see anything that is above 2 minutes. And if it's all planned to be with that resolution, less than 0.5 millimeter in plane, I would say that this is quite impressive, even with a 3 Tesla system.
Yeah, exactly. It was kind of our challenges when we planned the session. I mean, to not going above 2 minutes.
And I know that the point of this session is not to focus too much on the workflow at the user interface, but we have a session dedicated for this tomorrow morning, where Jeremy and the team will really go into the detail of how you can really fasten your workflow thanks to the air technology. So if this is of interest for you, stay tuned for a tomorrow morning session with exactly the same link to follow.
Exactly, yes. Thank you, Bastien. Feel free to join us tomorrow morning. Okay, so I think our knee examination is now positioned. So you can see 3 plane PD FATSAT and 1 T1 plane. So while it's running now, let's have a look of the first imaging that we have available now, our T1 sagittal.
I think, Jeremy, it's interesting to point out that we acquired the knee at the extremity of the air coil. And as you can see, the scan time of all the knee examination is less than 7 or 8 minutes. And you can see very clearly the sharpness of the images. So first, thanks to the Airicon DL image quality, and also thanks to the air coil that has a high number of channels with this new technology of air.
Exactly, Rashid. And what we can do here is to compare. On the left side, you have the sequence, you have the data set by applying Airicon DL technique, so deep learning based reconstruction algorithm. And on the right part, I displayed exactly the same data set, exactly the same sequence without applying Airicon DL. And I think the images are talking about themselves, the amount of signal that we are earning here. Even if with T1 there is no lack of signal, but it's quite impressive. I mean, and the sharpness, thanks to the fact that we are removing Gibbs artifact, we are improving the sharpness. And look at it here on the cartilage surface and the cartilage interface. It's quite impressive that it's like we have more spatial resolution, and it's exactly the same sequence. Even here we can see that we can distinguish the different layers here. And I think this is really the point with Airicon DL. It's that you don't have to be afraid to zoom on your images, because you are really magnifying the details, and you are not removing any relevant information, because this is not a filter, because we work at raw data level. We are not working on an image level like a filter could do. So this is for the T1 images. I hope that on your screen it's as clear as we have here in the MR Customer Center.
Yeah, honestly, Jeremy, I think that you would not see the difference with a transmit-receive dedicated knee coil when it comes to this level of resolution.
Exactly. Yes. As a reminder, we are scanning again with an anterior array coil, air coil. And let's make the same comparison with here the sagittal PD FATSAT. So here the amount of signal that we are removing is really, you can see it really more than on the T1. So we are removing only noise, and again, look at the sharpness, look at the details. I bet that if we are showing those images to radiologists or radiographer, they could not think that it's not a rigid coil images. And again, I would highlight again the acquisition time, 1 minute 42. So it's really a standard fast protocol with high spatial resolution and high signal noise ratio. So this is really the point that RSNA is a win-win technique. It's, I think, the first technique on MR field, which gives you the possibility to win at the same time in terms of signal, in terms of spatial resolution, and in terms of acquisition time, which is, I think, quite amazing. I was radiographer in the previous lives, and I could not imagine that you will have a technique that could give you this possibility. Let's work same way on the actual. Oops, sorry for that. And actual, look at the cartilage. Again, it's exactly the same data set. Here with RSNA, and on the right side without. And here, I think if you have a small lesion in the cartilage here, you will probably not have any trouble to describe it and to look at it.
What is interesting, Jeremy, is we reduce the scan time below the 2 minutes with a very high spatial resolution. And of course, at this spatial resolution and at this scan time, we have a lot of noise in the images. But by using the RSNA, what we can notice very clearly, we can see where we have a lot of noise in the bone, for example, we can see the structures with the RSNA. So RSNA helps you to extract the information even in the noise, as you can see in the patella and in all the bone.
Thank you. I think this is the time now to go down to the leg.
Rachid, this is Gilles. There is a question in the chat from Daniel about any artifact known because of RSNA. Can you answer that?
Excuse me, artifact known?
Is there any artifact that we know about RSNA?
RSNA does not create artifacts. The only thing you can have is the artifact you have in the images that are with or without RSNA you have in the images. And RSNA only do two things. By reconstructing the images in the K-space, RSNA remove the noise and the ringing artifacts. We cannot see the ringing artifact in MSK, for example, for the brain. We can see sometimes some ringing artifacts because what is interesting with the ringing artifact is we keep at the maximum the spatial resolution information. That's why it's interesting to have this kind of artifact, because that means we are not filtering the images too much to remove the spatial resolution information. And what is interesting with RSNA, it's the removal of these ringing artifacts and, of course, the noise, and we keep the native spatial resolution of the images. And this is also, that's why, if we compare an image without RSNA and with RSNA, we have also more information in terms of spatial resolution. So that's why we can see also more details in the RSNA images. So there is no artifacts created with this technique.
There is no trade-off at all.
And I don't see any for the moment. And I hope it will be always the case.
Thank you for this question, Gilles.
And the customer as well. Thank you for this very interesting question.
Thank you very much. I want to highlight what I just planned here. I plan on the leg coronal T1 with a matrix of 1024 by 1024. So high spatial resolution. It's 0.4 by 0.4 with a field of view of 42. So I think we will push the limits of air coil by doing that. Today we are really challenging this air coil. We really want to challenge it to give you the possibility to see the large panel of the things that you can do with this coil. And I plan also this one.
Yes. Just a remark about the T1. The slice thickness is 3 mm and the scan time is 1 minute 30. That is also a challenge.
Exactly. Oh, I'm sorry. Here we are. And an actual T2 with a small field of view and again, high in plane resolution to really show you this versatility between large field of view and high spatial resolution.
So just a remark for the knee, we were at the extremity of the air coil. With this axial, we will be at the middle of the air coil. And when we will go to the ankle, we will be at the other extremity of the air coil.
Look, I displayed here the whole knee examination. So in 7 minutes, by using air coil, 0.4 in plane resolution, 3 mm slice thickness. And this is the kind of result you will obtain on your patient in your daily routine. We can do the same kind of focus on coronal plane as we did before. Again, with and without Ericon DL. Same window level. Again, don't be afraid to zoom on your images. And here it is.
And Jeremy, if I can comment here, you know, knee MRI is typically the kind of examination you have at the end of the day, and you might be late on your schedule. What's interesting with Ericon DL, it gives you this extra flexibility to speed up scan time if you really have to keep up with your schedule. I think you would agree that we still have some room for acceleration on the left image that you display. So, for example, if you have to even faster to catch up on any delay, you could even accelerate or increase a little bit slice thickness. So that's really a new tool in order to speed up productivity while maintaining image quality and diagnostic confidence.
Yes, this is what is amazing here is that it's like we feel we are not at the limit already. We still have some space to even push further the sequences.
And remark as well, in one remark as well, Bastien, at the end of the day, of course, you have to fight against the delay, and by using this air coil, the size of the knees, it's large. You can do on very small patients, and you can do as well on very big patients because this coil is very big, and you can wrap the coil inside itself, and you can have more RSNA. So it is not a problem to wrap the coil with this, depending on the patients. You can have small and big. So there is no, I would say, dependency on the patient with this coil. If you have to perform a knee examination, of course.
So we arrived at the last 5 minutes. So this is the time to arrive at the ankle part. So let's plan a sagittal T2 fat sat on the ankle, and let's run it. Then we will have a look of the leg sequences that we run. Okay. Let me first position the shim box. Okay. And now the slices.
So in the meantime that Jeremy is positioning the slices, it's interesting to notice at the same time the spatial resolution is 0.4 by 0.4 native. This is a native spatial resolution, and 3 mm for the slice thickness, and the scan time is below the 2 minutes. And also we are at the extremity, other extremity of the air coil. So this will be interesting for you to see what is the coverage of this coil as well. If you have to perform long bone examination or a specific dedicated localization, for example, the knee, the ankle, in this live scanning session, what we wanted to show you is you are able to perform knee examination, long bone, ankle, without changing the coil positioning.
So have a look. This is the images that we scan on the leg. So this one, remember, 124, 3 mm, 1 minute 30. And what is quite impressive here is that you can almost use this one and zoom on the articulation. We have a really nice homogeneity of signal and still really high SNR with a really high spatial resolution. It's I think those images, or we can maybe also display the actual from the knee here to show you that this is the air coil and air recon DL story. You can work the way you want. Large field of view, small field of view, high spatial resolution with small time acquisition and high image quality. I think this is like the summary of the session here. Do you have some question in the chat box, Bastien?
Yeah, there was a question from Daniel. It was saying that the images look a little bit maybe too smooth. So I mentioned that you can actually adjust the strength of the air reconstruction from low to high. And this was a very important feedback that we had when we tried this feature with early clinical user. They really wanted to have that flexibility because, you know, the eye may want to adjust to a different level of signal to noise ratio depending on the way you used to see MR images on your scanner. And also, you have the capability always to save the original image that would be with a conventional reconstruction. We know that there will be a learning curve so that radiologists get used to artificial intelligence reconstruction. So to facilitate this learning curve, you can always compare what the image would have looked like with a typical reconstruction. That's what Jeremy is showing you in the patient list. You have both images at the same time.
Yeah, and also it's interesting to I have some feedback from radiologists who is specialized in MSK, and when you compare the native images with this high level of smoothing, not smoothing, reconstruction, I would say, Ericon DL reconstruction, he said, I don't lose any information. And I think it's just a question of to be acclimated of this very without noise images. And of course, any customer will go to say at the end, okay, even myself, I was not convinced at the beginning. I wanted to work with a medium level, and little by little, I'm convinced that the high level of filter of the Ericondial reconstruction is very good, because I see more things because I remove the noise in the images.
And we have here the result on the on-call. So I have to admit that the position is not a physiological position, anatomical position, but it's the quality and again the detail on the cartilage and on the bone.
Maybe Jeremy, you can zoom on the joint, on the ankle joint. Yeah. And you can do the same contrast at the right side. Okay, and you can see the information are not are always here, and you can see the details of the images when you compare the native and of course the original one. So the native are at the left, the original, the Ericondial images are at the left, and the original one are at the right. And as you can see, you are able to see more details in the images when you apply the Ericondial, because you remove the noise, and the noise, when you are used, you know that the noise remove the information. And you can see also some ringing artifacts that are also removed in the Ericondial images.
Thanks a lot, Rashid, for those explanation. I think we are at the end of the session, even more, 2 minutes left. So it was really a pleasure for us to demonstrate you that. I think you really taste this air story with air coil, Ericondial. I hope you enjoy that. Feel free to come to our booth and ask your question, ask for a demo, and hope to maybe see you tomorrow for next scanning session. Have a great day and enjoy your Congress.
Thank you, everyone. Have a good day.